Alright, what is going on, guys? I'm Turkey here, and welcome to what's my first of general programming tutorials. This is my first one. I'm not sure how many I'm due or if I'm going to do any more in the future, but I had some people asking me to do a tutorial here on my maze generator, which is right here, and just kind of how it works and just explain, just explain how it works. And so what I'm going to do here is I'm going to do a general visual pseudocode here so that you can take the knowledge that you see from this and apply it to any programming language you want. And I coded this in Java, but you should be able to take the knowledge from this and code it in C++, C, Haskell, whatever you so wanted. It's really up to you. But before we start, this is called Prim's algorithm, is what I'm using here. And it's just a maze generation algorithm, and that's what I used for mine. And basically there's three steps to this. The first step is taking a grid and assigning everything in that grid to a wall. And that's what this is right now. This black here is all walls. And I hit the spacebar here, I'll start it and I will start the generation here. And this actually did two steps of the generation. The rest of the things are in one, but this is the only one. This is in two steps. So the first, what it first did is it started in this location. I have my maze starting from the top left. If you so want, you can have yours from the bottom left, bottom right, top right, or even the middle if you so wanted. It's up to you where you start it, but you gotta assign one place for the maze to start generating from. Mine's the top left. And so it does when it gets to that first location. It looks in all four adjacent locations. So it starts to the north and goes, is this a valid location we can move to? And in my case, I have a border around this whole maze. So the computer goes, nope, that's not a valid location we can go to. And so it moves to the next one, over to the east. The east, yes, this is a valid location we can go to. And so what it'll do is it'll add it to a list of possible locations we can go to in the future. Same thing with the south, this one can be added as well. But the west, that's a border, so we cannot go there. And then what it does is it takes that list, it picks a random location in that list, and it goes to that random location it picked. This happened to be the east here, and what it does is does the same thing as what it did for that starting one. It looks to the north, east, south, and west, and it adds the east and south to that running list of possible wall locations to go to. And it pretty much keeps doing that, as you can see here. Now it chose this location here, added that south position to the list, keeps going, go off further this way, and just keeps going, keeps generating, and you can see it just keeps adding new locations to that running list, and keeps branching off random locations, random directions. And you see every once in a while, these red squares, they turn black, and just nothing happens. They just turn black for some reason. And that is because when we add those locations to that list of possible locations to go into the future, we don't know what the maze is going to look like when we end up going back to them. So when we go back to that location after choosing it from that list, we have to run a secondary check on that location to make sure it's still a valid location to go to. And in that case of these locations here, we got back to them and we said, well, there's a wall here, a wall, or a non-wall here, sorry, or non-walls all around here. And well, it'd just be silly to put a non-wall there. And if we didn't have the secondary check, this whole thing would just be one blob of that gray color. So that's why we have to have the secondary check to actually make the maze. The secondary check is what makes the maze in all. So you can see the maze just keeps generating here. I will let it run out till we get to near the end, and I'll rejoin you guys then. Alrighty guys, and here we've come up on the last step of this maze generation here, and that is telling the maze generator when to end the generation, when the generation is over, when to stop. And that's fairly simple because, well, if you're making a generation, you gotta have a loop somehow, somewhere, to make it so that it constantly loops through and keeps picking those locations. And well, to end it, you basically just end that loop whenever that list of walls that you have of possible locations to go to runs out. So in this case, it'll run out in 2 more, and that's the last little allocation, and now that list is empty. We're done. So, yep, it's as simple as that. It's just go through it again. It starts off by, uh, sorry, and yep, and so basically, let's run through it again. You start by just assigning this whole grid to walls. You pick one location to start with. You run through those locations, assign possible locations you go to some sort of list. You keep running through that list, keep branching off in those directions. And remember, we're gonna have that secondary check so that the thing just doesn't become one big non-wall. And yeah, it's as simple as that. So if you want more information on how to make a maze generation, just search Prim's algorithm. It should be fairly easy to find. But yeah, thank you guys for watching. This is my first tutorial here. I'm not sure if I'm doing more in the future. If you want some tutorial some sort, feel free to post it down below. Please try and keep it to general programming knowledge type stuff. Not really kind of one language specific. So yeah, so that's gonna do it. So I will catch you guys all later.